Hi everyone, today I will demonstrate lab 2 arithmetic equation and operation, question 1, 3 and 5. So let's start with the question 1. For line 1, the value of bar 1 is moved into AS. AS only changed at the last four hexadecimal digit because AS is the lower 16-bit part of EAS is 0001. So after we step over, the value of EAS is now 00860001, which means that the value of AS. So for the line 2, the value of part 2 is moved into PS, which means that EPS is now 00800009. So the PS value is 0009. For the line 3, the exchange operation swap the value of AS and PS. So now AS is 0009 by PS is 0001. So for line 4, the value of AS is moved into var 1, which means that the value of var 1 is now 0009, as we can see at the wash. So for the line 5, the value of PS is moved into var 2. So now the value of var 2 becomes 0001. Finally, after the dump strike, we can say that the value of EAS is 00860009 by EPS is 00880001, which means that the value of AS is 0009 and the value of BS is 0001. Now, we will continue with question 3. Let's take a look at the register and the watch output during the program execution. Here we can see that the value of var 1 is 5, var 2 is 10, var 3 is 20, and var 4 is undefined value. So for the line 1, the value of var 1 is moved into EAS, which means that EAS now is 5. Now for the line 2, the math operation will multiply the value of EAS with var 2, which means that 5 multiplied by 10, which is 15. Here in EAS, we can see that the value is 32. 32 is actually the hexadecimal value of 50. Now for the line 3, the value of var 3 is added into EAS, which means that 50 plus 20, which is 70. And here EAS value is 46, which means that it is a hexadecimal value for 70. For the line 4, the value of EAS will decrement by 1, which is 70 minus 1, which is 69. So the value of EAS is 45, which is the hexadecimal value for 69. So the final answer of EAS is 45, which is 69 in decimal value. Lastly, I will demonstrate question 5. First of all, 0 will be moved to DS to clear the value of DS. In the register, the value of EDS is 00760000. DS only changed at the last four hexadecimal digit because DS is the lower 16-bit part of EDS. You can look at the watch for the clearer value. Next, the value of 1000 is moved to AS to load the 1000 into AS. And then the next step, CS is loaded with 25. Next, the math operation will multiply AS by CS. So the calculation is 1000 multiplied by 25, which is 25,000. Since the result is larger than 60-bit, it is stored across two registers. DS will hold the high part and AS will hold the low part. So after the execution, DS will store 0002 and AS will store 5000. Finally, it will display the register output DS to AS, which is 0002 to 5000.